Yeah, we are familiar with this acid-base chemistry lab. Okay, and so we'll start with our experiment. We'll take 250 ml beaker from here. We'll take from strong acids, we'll take 1 molar HCl. There it is. And from strong bases, we'll take 1 molar NaOH. Okay, and we'll also take indicators. Take phenolphthalein as an indicator. Okay, we're gonna need a burette because we're gonna do titration. Okay, so I usually assemble everything whatever I need, and so in the beaker we'll take acid, we'll add 25 milliliter of acid. Okay, and you can check if the volume is 25 milliliter. You can check the pH. Yeah, is 0. It's so you can see from the ionic product of water there is no OH ions in here, all H plus ions. Okay, and so we keep it there. We take phenolphthalein indicator. I usually add 0.25. okay, so add phenolphthalein indicator, and you can take out. We are pretty much done with this acid, done with the indicator, and you can check the final volume of the flask. It's 25.25 milliliter because we added 0.25 ml of phenolphthalein indicator. Correct? Alright, so now it actually even shows the pH of the burette. It's funny. It shows that it is pH 7. I guess, yeah, that's quite funny. Alright, yeah, we shouldn't. It's a glassware, right? Alright, so we take NaOH, we add 50 milliliter because it's a 50 ml of burette. We have 50 ml of NaOH and take that aside. Alright, now all we need to do is to do titration. So we add this in there. Oops, okay, and we add, so you can see the volume of NaOH. You can check the ionic product of water, yeah, and check the pH. It's 14. So everything consistent with our setup. All we need to do is add NaOH into the beaker. Okay, and so now the question is in, let's talk about this acid, and can you calculate how many moles of HCl in there? Yes or no? Can you calculate how many moles of HCl is in the flask? We took 1 molar solution and we transferred 25 ml of it in here. So we can easily calculate how many moles of HCl is in this flask. Correct? If there is 1 mole in 1000 milliliter of solution, then how much is there in 25 milliliter of solution? Yeah, so basically 25 divided by 1000 and we get 0.025 moles. Yeah, so 25 divided by 1000. Yeah, because it's a 1 molar solution, and so 0.025 moles of solution is in there. Okay, alright, so we take this, put it here, yeah, and now we start adding our base into the flask, into the beaker. We add 0.5 ml of base in there. Okay, each time. Okay, so we add 2. Okay, so you can see that we have done this before, so I'm going a little faster. Yeah, so you can see the volume increases and the H plus and OH minus ion changes. H plus ion goes down, OH minus ion goes up, the ionic product of water stays same. Okay, I'm sorry, pH also increases. Yes, that is correct. So we keep on adding, yeah, and so now the volume is about 39, 40, yeah, and you can see the pH is going up, and so now, so at this stage we have 49 milliliters of total solution. That means we have, so now we have 50.25. okay, of this 50.25 we have 25 ml of HCl and 25 ml of NaOH. Both of them are 1 molar solutions, correct? Yeah. And so the pH is 7. At this time the neutralization reaction is done. Yeah, all the acid has been neutralized by the base and there is no excess of base. Okay, so we have equal molar of HCl and base in there, we can say that, correct? That's why the neutralization reaction is there. You can check the H plus and OH minus ion concentrations here. They are equal, almost equal. It can never be exactly equal, but it's almost equal. Yeah. And so now we add a little extra of that, and obviously the solution should change to pink because we have an indicator which is phenolphthalein, which is colorless in acidic solution, but it is colorless in acidic and neutral solution, you can say, but it's pink in alkaline solution. So if the pH now, if we add 0.5 ml, so let's just add 0.5 ml, and you can see that the solution is alkaline now. You can see that the hydrogen ion concentration is much more than H plus ion concentration in the solution. Okay, and as a result of that the solution turns pink. Okay, so this is the end point. Now you realize that the solution, the neutralization reaction was done a little earlier than this, but we needed to add a little extra of that NaOH so that we can see the change in the color of the phenolphthalein indicator. Yeah. Okay, so now, so essentially we added how much, 25 ml of NaOH in there. Yeah, from NaOH, yeah, from the burette we added about 25 ml of NaOH in there. And so can we yeah, so we calculate, we can calculate this, how many moles of HCl was there. Can we also calculate how many moles of NaOH we added into the flask? We added 25 ml exactly. Yeah, we added the same moles of HCl as that of NaOH. Sorry, we added same moles of NaOH as that of HCl, and that's why the reaction is complete neutralization reaction at the end point when the pH was 7. Yeah, not the extra 0.5. So this is, so we know that the moles of HCl and moles of NaOH in this flask is same. Yeah, at pH 7, or were same at pH 7. Just before we added extra 0.5. Okay, now I think we'll have to go back to notes. I will stop the recording and then we can go back to the notes and see if we can solve the same equation using the concept of equivalent. Okay, and see if that adds up. So we what we're saying is that we said in the notes during the class that in a neutralization reaction, number of equivalents of acid is equal to number of equivalents of base. Correct? Yeah, in the class notes we said during the acid base neutralization reaction. So they should add up. Basically we should have the equivalents of acid and base should be same. We also said that when you solve the problems using equivalents, you don't really need to balance the equation. Yeah, but when you do with the moles, you need to balance the equation. Yeah, so we'll try and try to do that. Okay, so I'll stop the recording here and then go to the notes. Okay.